All right, today I'm going to talk to you about more quadratic stuff, and the stuff we're going to talk about is transformations. So how does the graph compare to what is called a parent graph? Is it shifting to the left, shifting to the right? Is it flipped upside down? Is it fatter? Is it narrower? So these are the things that we're going to talk about today. So we're going to compare a graph to what is called the parent graph. And the parent graph of a quadratic function is y equals x squared. And if you were to graph this y equals x squared, you would get a parabola that's vertex sits on the origin and it opens up. And it looks just like that. And you can always graph this and you can visually see. So if I go to y equals, and I type in x squared, and I go to graph, which I have never used this calculator here. Let me see here. Where's graph at? Oh, there it is. Second. No, I want to graph it. Oh, I just say graph. All right. Long time there. So there is my graph, and I can actually zoom in and zoom out on my graph, but that is the parent graph. So what we're going to do is we are going to compare maybe that function with something like 1/2 x squared plus 2x minus 4. And so this is a quadratic. We talked about this already. We can find the vertex and the y-intercept and all that good stuff. So if I hit graph and I can zoom out here, maybe. Okay, there we go. So you can see that my parent graph is the one sitting at the origin, and then you can see that the vertex of the new graph I put has been shifted down and to the left, and the graph appears to be wider. And so we can actually describe these things without actually having to graph them on any kind of calculator or Desmos or anything like that. So I'm going to talk to you about how we can determine those things. All right, so back to my worksheet here, because I lost my worksheet. Sure did. All right, so again, parent graph is y equals x squared. It is at the origin. It's a parabola that opens up. And so, of course, now we can talk about how we can compare other quadratic functions to this parent graph. So anytime they ask you to describe the transformation, you're asking to compare it to the parent graph of y equals x squared. And so standard form of a quadratic is y equals x squared plus bx plus c. And so most of our equations may be written in this standard form. And if they are, in order to talk about the effects on the graph, you have to look at A and you have to look at the vertex. Okay, so how does A affect my graph? Well, the absolute value of A, we're only going to look at the number itself. We don't care if it's positive or negative at this point. So if my A value is greater than 1, such as like 1.5, 3, 4.5, 16, anything bigger than 1, what this is going to do to your graph is it's going to stretch it vertically. So your graph will be stretched vertically. And if you imagine a piece of paper that's stretchy and you put your U, your little parabola, on the stretchy paper and you pull that paper vertically, it causes your graph to get skinnier. It's going to make your graph skinny. And another word we use is narrow. Okay, so you can have a little skinny graph, a little narrow graph. And if your A value is between 0 and 1, like 1/2 or 2/3 or 1/3 or something like that, then your graph is going to be stretched horizontally. Think about stretchy paper, you got your U on it, and you're going to pull it horizontally, then your graph is going to get fat. I don't really like that word fat, but it visually explains that the graph is going to get wider. So these are some words that we use, but just know that stretched horizontally is the more mathematical term. Now, again, that's only if we're looking at just the A value. We don't care if it's positive or negative. Now, what if your A value is negative? If your A value is negative, we already kind of know that because we talked about that when we were graphing our quadratics. And so if my A value is negative, this is a reflection over the x-axis. So there may be multiple things you can talk about your a. So if I have an equation like y equals negative 1/2 x squared, this is a reflection because it's negative. So it's going to be reflected over the x. And because of that 1/2, remember 1/2, that's between 0 and 1, so that's going to make my graph wider. Or you can say stretched horizontally. So be careful describing the a. It can have two effects. Of course, it can't be skinny and fat because that wouldn't make any sense, but it could definitely be reflected and skinnier, or it could be reflected and wider. If my a value is a 1, then it has not been stretched at all. It's going to be the same width as the parent graph. So just keep that in mind. If you have a value of 1, it does not affect the width of your graph. All right, so that is how we can compare the width of our transformation of a graph to the parent graph. The next thing I want to look at is how does the vertex affect the graph? Well, we know how to find vertex. We would do negative b over 2a, take that value and plug it back into the equation, and that gives you the y coordinate of the vertex. And we also use h comma k as our vertex because we generally, when we talk about transformations, we talk about h and k versus x and y. All right, so just, keep that in mind that h and k is what we're going to use for our vertex. And this actually works for all sorts of different types of functions. We have rational functions we're going to talk about. We have radical functions we're going to talk about, absolute value functions, and they all have a vertex sort of point. They don't necessarily come on vertex if it's a rational or radical function, but we use this value of h and k. So we will describe a transformation by using the letters a, h, and k. Probably for the next few days you'll hear me say a, h, and k. Talk about a, h, and k, especially with other functions as well. A, h, and k is the way to go. So your graph is going to shift to the right if your h value is positive. If your h value is negative, your graph will go to the left. And so if you can find that vertex, then that vertex will tell you the direction that your graph goes to the left or to the right, and where it goes up and down. If my k value is positive, my graph is going to be shifting up. And if my k value is negative, my graph is going down. And however many, like if it's a positive 3, then your graph goes up 3 units. All right, so as long as you can describe a, h, and k, then you're going to be able to describe the transformation. So let's take a look at an example. You need to find a, h, and k. A is super easy. It's not hidden. It's just sitting there staring at you because this is ax squared plus bx plus c. And so my a value is the number that sits in front of the x squared. And we talked about that already when we were describing how we find the vertex and those kinds of things. So off to the side here, I'm going to label a equals 1. H, I don't know yet, I have to find it. And k, I don't know yet, I have to find it. Remember, h and k come from the vertex. So how do I find the vertex? You do negative b over 2a. So my b is 6. This becomes negative 6. My a is 1. So this is negative 6 over 2, which is negative 3. So that gives me the first half of my vertex. Do you remember how to get the second part of the vertex? That's right, you're going to take this negative 3 and plug it into the x's in the equation. So I'm going to replace my x's with negative 3. Put parentheses around the number you are plugging in. It is so important. So now I am plugging in my negative 3, and I'm going to pick up my calculator, and I'm going to type in parentheses negative 3 parentheses squared plus 6 parentheses negative 3 parentheses plus 2. And so all I have done is put this entire equation, this expression right here that I have in the box, put that into the calculator. Or you can do order of operations. You get 9 minus 18 plus 2, negative 9 plus 2, and you get negative 7. So either use your mental math skills that you may have or plug it straight into the calculator. Okay, get rid of some of this junk. I don't like putting boxes around stuff unless it's my answer. OCD like that, I guess. All right, so recap, find the vertex. Negative b over 2a, whatever you get, plug it back into the equation to get the y-coordinate of the vertex. So now I know my h is negative 3 and my k is negative 7. So now I can talk about the transformation. Remember I said earlier, if your a value is a 1, it does not change the width of the graph. So this has no different, it doesn't get fatter or doesn't get skinnier compared to the parent graph. So there's no difference there. So let's talk about h of negative 3. Remember h, if you look up here at the vertex, a negative h is going to shift my graph to the left. So this is left 3. And a negative 7 on the k value tells me we're going down 7. So that is how you would describe that graph, compare it to the parent graph. And again, I can pull this up on my calculator. I'm going to forget this equation. What is that? Plus 6 plus 2. So if I pull this up on my calculator, I go to my y equals, I'm going to clear that out, and we just had x squared plus 6x plus 2. And when I graph this, you can see the vertex. Okay, here's my little vertex point. You can see that from the parent graph, which was at, I can't even get there. It was at 0, 0. And then it's been shifted to the left 3 and down 7. And this is that little calculator app that some of you guys may have loaded. If not, you can always look at this on Desmos as well, and you can see the vertex point. And the width of the graph, if I take a look at the width of this new equation compared to the, I can't get my little, there it goes, the width of the parent graph, they're the same width. Okay, so they had the same width. The only thing that's different is that the vertex moved from 0, 0 to negative 3, negative 7. So my graph has been shifted to the left 3 and then down 7 points. Okay. I hate that it doesn't keep on everything I just wrote. So now let's, you can pause the video and you can try the your turn problem down here at the bottom. You're going to describe that transformation. So find your a, h, and k, unpause the video, and see if you got them correct. All right, so my a value is 1/2. My h, I don't know yet, and my k, I don't know yet. To find h and k, remember you have to find the vertex. So to find the vertex, we're going to label our a, b, and c. And the equation is negative b over 2a. Negative 4 over 2 times 1/2 is 1, so my x-coordinate of my vertex is negative 4. Remember to take out those x's and plug in a negative 4, so you get 1/2 times negative 4 squared plus 4 times negative 4 minus 1. And this is where a calculator comes in handy, so hopefully you plug that into your calculator. Please make sure you put parentheses around your numbers that you're plugging in. It helps kind of contain that negative sign. And so if you did this, hopefully you got a negative 9. And so my h is negative 4 and my k is negative 9. Again, that comes from the vertex. And so now I can describe this. Because my a value is 1/2, and from our notes earlier that you should have written down, mine disappeared, that a 1/2 means that my graph got wider or stretched horizontally. So you can put wider or you can put stretched horizontally. Negative 4 means we went to the left 4 units, and a negative 9 means we went down 9 units. And so if I graph those, I could compare, but you don't have to graph them to compare it with the parent graph, because that is what would happen. Your graph would get wider. It would shift to the left 4 and down 9. Pretty simple. You just have to remember a, h, and k. A is staring at you in the equation. H and k you have to do a little bit of work to find. Okay. So now let's go to the next page. Flip your paper over. And we are going to talk about vertex form. Vertex form is new, and I know we have studied quadratics in Math 1. I don't know that your teacher probably told you anything about transformation, so that's probably new as well, but vertex form I know is especially very new. Vertex form of a quadratic is y equals a parentheses x minus h squared plus k. And the reason why they call this vertex form is because remember h and k is your vertex. And if you notice in the equation, h and k is right there. So I don't have to do negative b over 2a to find my vertex. All I have to do is pluck it straight out of this equation. So with that being said, you have to remember, though, some things, because a lot of students will miss their h. So think h is, in the equation, it's negative. So for example, I'm just going to see if we can identify some pieces here. So I'm just making up this equation. So say I've got 1/2 times x plus 1 squared plus 3. So my a value is 1/2, so now we can talk about the width of the graph. H, most students would put 1, but if you take a look, it says plus 1, and the equation says minus h. So absolutely that should be a -1, because if I plug that in, 2 negatives equal positive. That's why they ended up with a plus 1 in the equation. K, very simple, it is what it is. So you might want to take a little note here. Think opposite when you're pulling your h out. Think opposite for h. Okay, so it looks like a plus 1, but it's really going to be a -1. And so then we can talk about 1/2 is making my graph wider, -1 shifts it to the left 1, and k makes that a up 3. So let's take a look at this example. It's in vertex form. My a value sits up front outside of the parentheses, so there's just a negative sign there, which is a -1. Okay, remember your a sits in front of the parentheses. H is inside the parentheses, and you got to think opposite. It looks like a +4, but it's really a -4, and that's because the formula for vertex form of the equation says minus h on the inside. All right, and then k is +1. All right, so 1 on that a value does not make my graph any wider or narrower, but that negative out front tells me it's a reflection over the x-axis. So this is a reflection. You can put over the x-axis, or you can just put reflection, would be fine by me. -4 is a shift to the left 4, and a 1 on the k value tells me we're going up 1 unit. So that would be the transformation, how you would describe that graph's transformation. All right, so pause the video, try the your turn, and see if you get the same thing I get. So for a, I got 2. H, I got regular 4. Think opposite on your H. K, it is what it is. So an a value of 2 makes this thing narrow or stretched vertically. 4 is positive, so we're going to go right 4. And K is positive, so we're going up 3. So how did you do? Did you get it right? So just make sure you study and you know those a values. If a is a fraction less than 1, then it's going to be wider. If it's a whole number greater than 1, then it's going to be, or any kind of number greater than 1, then it's going to be narrow. Okay, next thing we're going to look at, it's a lot today, I know. We're describing transformations, A, H, and K. But now we're going to talk about some more stuff with vertex form. We're going to talk about how do I write an equation from standard form to vertex form. So we're going to take an equation from standard form and we're going to write it into vertex form. Well, what we need to do is we need to find A, H, and K. Once you know A, H, and K, you're going to simply plug it in to the vertex form. It's that simple. All right, so A is 1. It's the number in front of the x squared. H I have to find. K I have to find. How do I find them? By finding the vertex. Okay? So to find the vertex, remember that's -b over 2a. And in this equation, if it helps, label your a, b, and c. In this equation, b is already negative. So when I plug it into the vertex form, it becomes positive. 2 times 1 is 2. 4 divided by 2 is 2. So that is the h value, because that is the x on my vertex. Now remember, I replace all the x's with the number I just found, which is a 2. So I got 2 squared minus 4 times 2 plus 1. So at this point, I'm going to use my calculator, or you can use your mental math skills that you may have. And so I get -3 when I've plugged in that 2 value. So that is my k. So I have found A, H, and K, and I'm not describing this time, but if I had to, then I could. But I want to write an equation in vertex form. So once I have my A, H, and K, I'm ready to plug it into the formula, which is written y equals A times x minus h squared plus k. So here we go. We're going to say y equals A. You don't have to put the 1 there, but it's good practice. X minus my h, which we found to be 2. Don't forget your parentheses and your squared. And then plus k, so I'm going to put minus 3. So find A, H, and K and plug it into the vertex form. All right, your turn. Pause the video, work it out, and see what you come up with and see if it's the same thing I get. All right, so A is -1/2. H, I don't know yet. K, I don't know yet. The only thing I could pull from the equation was A. So I'm going to do -b over 2a. If it helps, you can label your A, B, and C. So B is already negative, it becomes positive. 2 times -1/2 is -1, so that makes that a -6. I'm going to replace my x's with -6. So I get -1/2 times -6 squared minus 6 times -6 plus 3, squeezing that in there. So -1/2, plugging this into my calculator, and hopefully you did as well. And I got 21. Ooh, that's a big old number. I wonder if that's even correct. Is that what you got? I'm gonna cheat here and just make sure. I don't think I put my negative in there. Maybe I did. Oh yeah, I believe that is correct. So I got -6 and 21. So now I can describe it, but that's not what we want to do. We were asked to make sure you always read your instructions. We are asked to write this into vertex form. So y equals -1/2 parentheses x plus 6, because in the formula, remember, it's x minus h, so a negative is a positive. Don't forget your squared. And then plus 21. So that is vertex form of my equation. So you should be able to take standard form of a quadratic and rewrite it into vertex form by finding your A, your H, and your K value. All right. If you have any questions, remember you can always email me. All right, here's an example. We're going to write an equation of a quadratic that has a vertex. There's a typo there. Of a quadratic, what has a vertex? That has a vertex. Let me fix that. That's going to bother me. That has a vertex at 0, 4 and passes through the point 3, -1. So I've given you the instructions. You are going to plug into the vertex and a point into vertex form, and that'll leave you with an A that you can solve for. Then after you have solved for A, you're going to plug the vertex and A into the vertex form equation. So it sounds terrible, but it's not too bad. So the vertex, remember, is H, K. Your ordered pair is X, Y. So you have an H, K, X, and a Y. You're going to plug all 4 numbers into the vertex form, which is Y equals A parentheses X minus H squared plus K. So all I did was take my H, my K, my X, and my Y, and I plugged them into the form Y equals A, X minus H squared plus K. All right, so now I can use some math here and solve for A. So -1 equals A, 3 take away 0 is 3, squared is 9. To solve for A, I'm going to subtract my 4, so -5 equals 9A. Divide by 9, A equals -5/9. Okay, so A equals -5/9. Plug your vertex, here's my vertex, 0, 4, and my A value I just found into vertex form. So I'm going to now say Y equals my A I just found, -5/9, X minus H, don't forget your squared, plus your k value, and you are done. So find your a value by plugging in your point and your vertex into the vertex form, and then solve for a. And then you will have to rewrite your a and your vertex back into the equation to get your answer. All right, so pause the video, try your turn, plug everything in, x, y, h, and k into the vertex form, solving for a, and then take your a and your vertex and write the equation. Unpause the video when you're finished to see if you got it correct. All right, so my vertex is h, k, and it passes through a point x, y. So the first thing I'm going to do is take all 4 pieces and plug it in. So it's y equals a times h, x minus h squared plus k. So in this case, my k is negative, so I put minus 1. All right, to solve this, hopefully you did this part correctly. 1 take away 2 is negative 1. Negative 1 squared is positive 1. So all I did here was simplify this whole section using mental math. Use a calculator if you need to. I'm going to add the 1 to the other side. So 4 equals 1a. 1a is the same thing as a. So my a value is 4. Take your vertex and your a and plug it in and you'll be done. So y equals the a that we just found, x minus h squared plus k. And so there is my equation. All right, so recap, you should now be able to describe the transformation of a quadratic by describing a, h, and k. You can write vertex form using a, h, and k. And then if you need to take a point and a vertex, you would plug all that into vertex form, solve for a, and then plug that into vertex form again to get your answer. So just remember, to write vertex form, you need a, h, and k, and to describe a transformation, you need a, h, and k. H and k is the vertex. A is the number in front of the x squared. Let me know if you guys have any questions, and hopefully you were able to follow along and you have a practice worksheet that you will use your notes to help you. It looks just like this. The first part, you're going to write each equation into vertex form. So you will need a, h, and k. And then you will graph each function. And we have graphed already, so that 10, 11, and 12 is basically review. 13 and 14, you're going to take a point and a vertex and write an equation. So plug it into vertex form, solve for a, and then take your a and your vertex to write the equation. 15 is just a word problem evaluating the equation that's given. And then 16 is just writing an equation, and you'll have to find the vertex by looking at the picture, and then you can do that by using that 4 and that 10 to figure out what your vertex is. And then you can use any point on that parabola, which I would use. Let me help you out here. This right here is my vertex. You went to the right 4 and up 10. And so this could be your origin 0, 0. So there's your ordered pair, your point xy, and your vertex hk. So now you should be able to write an equation. Find a, plug all that into vertex form. All right, let me know if you guys have any questions, and I will see you guys soon. Bye.